My name is Elena McHale, and I will be presenting the work of Stephen G. Ike, Joseph L. Steffen, and Eric E. Sumner Jr. on CSoft, a tool for visualizing line-oriented software statistics. This paper was on the IEEE Transactions on Software Engineering, Volume 18, Number 11 in 1992. The paper has over 900 citations. Ike has an H-index of 27, is the founder of SSS Research, and has interest in visual analytics and visual business intelligence. His picture is on the right. Steffen is interested in human-computer interaction, AI, computer graphics, and computing and mathematics. And I couldn't find an image on him or the next author, which is Sumner Jr., and his father actually has an IEEE award named after him, and he was also the president in 1991. Unfortunately, I couldn't find much on Sumner Jr. or a picture of him. The research question in this paper is there a way to use visualization to better analyze large software systems? And if so, what feature should this system be able to display? The main motivation for this paper was the existing problem of understanding the statistics collected at the source code level of detail. This was especially difficult for large systems due to the volume of the code. On every large software system, line-level data is available but unutilized because of the user's difficulty analyzing. A few features of line-level data include revision control systems, or RCS, statistic analyzers, and profilers. RCS contains a complete history of the code. Static analyzers capture the definition, functions, types, macros, and more, and also where they occur in the code. And profiles perform basic block counting and indicating how often individual lines are executed. Aggregation was often used, but there was difficulty in gaining insight due to volume, but there was usually a need for more detailed analysis since aggregation discards the textual representation of the code. This paper took the approach of applying scientific visualization techniques by using CSoft. CSoft allows someone to analyze up to 50,000 lines of code simultaneously by mapping each line of code into a thin row. Red rows are most recently changed, and blue rows are least recently changed. There were 4 key ideas by using CSoft: reduce representation, coloring by statistic, direct manipulation, and capability to read actual code. Reduced representation displays files as columns and lines of code as thin rows. Color is determined by statistics associated with the line of code it represents. And direct manipulation allows the user to manipulate the displays to find patterns. Figure 1 shows a directory of 20 source code files containing 9,365 lines of code. This source code will be the same in all the figures of the presentation, but will be displayed differently to show how CSoft has different capabilities. Height shows how large the file is, and line color shows the age of each line. The newest is in red and the oldest is in blue, with a gradient of colors in between. Unfortunately, the figures are in black and white in the paper, so you can imagine red as being black and blue as being white. The scale on the left shows the color of the 461 changes and modification requests. CSoft displays line-oriented source code statistics by reducing each file into compact representations. So to be effective, displays must be clear and informative, must be easy and intuitive to human interface techniques for the user to manipulate and display, and must be a technique to allow users to read code. Therefore, the CSoft screen layout contains a file display, mouse-sensitive color scale, buttons, toggles, and a list of statistical names. The statistics used is highlighted in the right lower corner of the list of the statistics, and control structures are visible by indentation. On the color scale on the left, a user activates a value by positioning the cursor over it. The color is activated and the code lines are turned on. In figure 1, all the MRs are activated, so the lines of code are visible, but in this figure on the left, figure 2, MRs are deactivated and the cursor is positioned over 1 MR on the scale. When a mouse automatically activates or deactivates entities as it moves around the screen, it's called brushing. Figure 4 shows the file with the mouse cursor over it, and it shows the file has been changed 65 times, and the changes have all been occurring consistently since the file was created. Under the color scale, there is a number of activated statistic values and the total. At the bottom of the screen, you can print the current code line and statistical value. The user will manipulate and display to find different patterns. This paper uses an MR number, which is the modification request to a version control system, and it comes in date order, that is the smallest unit of program change, and is associated with programmers, developers, and features. CSoft has several different buttons that will alter the display. You can turn off the line indentation by pressing the indent button. The animate button causes the computer to sequentially display all statistic values at one time. Depressing the reading window causes C code text to be opened and magnifying box to be created to display the actual code. Figure 3 shows the code with indentation turned off and the color of each line tied to MR, which makes it easier to see the age of the lines. There are two types of MRs, which are new feature MRs and bug fixing MRs. Feature 9 on the left shows bug MRs in the red, or black in this case. In figure 10, the line color is tied to the user ID of the programmer writing each line. So files with lots of colors indicate that they have been changed many different times by different developers, and files touched by many developers usually have more bug fixes, which ties figure 9 and 10 together as a cause-effect relationship. This paper took an approach to visualizing software. The authors suggest to think of code, files, and lines as entities in an ordered database. As the mouse moves over portions of the screen, you are performing a series of database queries. CSoft activates the lines of code that resolve the database queries, and when you discover an interesting pattern, you can view the database directly. This approach applies to databases where there is interesting in the overall understanding of the structure and the query is based on a particular attribute. So since there is no point and click delays, it is easy for the user to experiment and probe the displays interactively. CSoft is predicted to be used in code discovery, new developer training, project management, quality assurance, system testing, software analysis, archaeological studies, code coverage analysis, and code execution optimization. The code discovery problem is when programmers must study the current code to determine which files contain an existing functionality and which lines to change within these files to meet additional requests. This is a difficult and time-consuming process. By using CSoft, a programmer can determine which lines were created to deliver an existing functionality, the programmer who created the lines of code, and the purpose of the nearby lines. The new programmer training is a problem that is faced by large projects and can see a lot of turnover. CSoft uses programmer training by allowing a global view of the source code. It can also answer questions about how files are organized, when they were last worked on, where the code is for certain features, and what the person worked on before. Project managers can monitor development to ensure projects are on schedule by tracking source code, identifying trouble spots, and finding spots that need to be reworked. Quality assurance inspectors use CSoft to determine if new code meets specification. System testers can determine which regression tests to run and based on the system functionality in the files that were changed. Analysts can understand the effects of different development environments and processes. In addition, it could evaluate the effects of the project age and size on efficiency. Finally, developers can display execution frequency data for each line, identify hotspots, and evaluate potential improvements. In conclusion, this paper describes a technique for visualizing stats associated with source code. CSoft is also valuable as an application to ordered databases. This is easy use of visualization and is valuable to all personnel when working on large software systems. Future work could involve addressing limitations of being unable to display more than 50,000 lines of code simultaneously. This paper did an excellent job of providing examples of the features of CSOC. There were even more than what I included in this presentation. The images helped to leverage the approach and show exactly how user-friendly CSOC is. They also solved the exact problem they originally wanted to address and provided a real-world use of implementation. This is my reference.